Welcome to DevOps project lab implementation. Okay, so project. So insurance aggregator project. Okay, so tools we are going to use Azure Kubernetes services, Azure Container Services, and static web app. Okay, so in the last previous project, we have completely deployed our application in AKS only. Okay, so in this application, we are deploying content in static web app and backend in AKS. Okay, so and also we have a database also. Okay, let's see how to do. Okay, technologies we are going to use. Okay, Azure Kubernetes services, Azure Container Registry, and static web app, and we have MySQL also. MySQL also. Okay, so this is a three-tier application: front end, back end, and DB. Okay, so we have Dockerfile and Kubernetes manifest. Okay, so we have developed a front-end application with the help of React.js and back-end application with the help of a Spring Boot. Okay, so Terraform for infra automation, and we have CI/CD pipelines with Azure DevOps. Okay, let's see. So this is the project file of in our DevOps project implementation web series. Okay, let's see. Yeah, project overview. Insurance aggregator portal. Okay, so where it is a web-based insurance platform that is designed to sell your insurance. I mean, purchase your insurance. You need to select the policies. So you need to enter your details like your name, nominee, age, Gmail, phone number, like this you need to enter. So once you purchase, the detail will be stored to the admin team. Okay, so this will reduce manual work. Okay, so goal. So main goal of these priorities, you need to deploy end-to-end deployment of your application in AKS and front-end application in Swagger or static web apps. Okay. So let's see. So this is the architecture. Let's see the yeah. Here we go. This is the portal. Okay. Say this is the portal where you have multiple type of insurances and where you need to click insurance details. So these insurance details will be get from backend. Okay. So you need to enter the details of full name, email, age, and nominee, and pay. Okay. So once you pay and purchase, okay. So the details will be go to the admin team. Okay. So you can see the admin team. So all the details will be able to see by admin only. Okay, so this is the whole agenda of this application. Okay, so this application will be deployed in AKS, front end will be deployed in static web app. Okay, so backend and MySQL should be deployed in AKS. So we have a nginx load balancer, so it will be route traffic to the backend services. Okay, you have ingress controller, so the path will be route to the corresponding backend service. Okay, so let's see how to deploy Azure services and DevOps tools we are going to use. Okay. So front end. So we will front end will be helpful for interacting with the user. Okay. So we will use a React.js application. Okay. So for backend we will use a Spring Boot application, and we will use a MySQL that will store your policy details and purchasing customer details. Okay. So containerized. Okay. So we will build your application as an image, and it will be stored in Azure Container Registry. Okay. So after that, we will deploy the application with the help of a CI/CD pipeline in the Azure Container Services. Okay. Yeah, we have a static web app. So this will serve your front-end page to global users. Okay. So and have Azure DevOps. So we will use Azure repository and Azure pipelines. So for repository storage and pipelines. Okay. And we have Terraform that will provision your Azure resources. Okay. Let's see. Yeah, this is the whole architecture. So, so this is the DevOps part. Okay, this is the container registry, and this is a resource group. Under that, we have Kubernetes services, we have static web app, and we have Nginx load balancer, that is a public API. Okay, we have Ingress. So under that, we have backend. Under that, we have backend deployment, and we have MySQL deployment. Okay, so front-end will go from here to, then it will route the traffic to load balancer, then it will go to Ingress. Okay, from Ingress to, it will go to backend services. From the backend services, data will be passed by the Spring Boot application. So the data will be stored to the MySQL DB. Okay, so in the the backend deployment, we have given all the details like MySQL host name and credentials also we have given in the, we have created a secret for MySQL details that will be fetched by the backend deployment. Okay, then utilizing it will be stored in MySQL pack. Okay, so this is the whole entire deployment. So let's see. So, so what we will achieve at the end of this course. Okay, so you can able to build the front end and back end application. Okay, okay, front end you will be deploying in static web app. So backend will be deploying in AKS. Okay, so you will write the Terraform script to provision all your cloud infrastructure. Okay, so we have all this all infrastructure. So like a static web app, Azure Kubernetes services and container services we have. Oh, of course, we have roles that all will be provisioned with the help of a Terraform code. Okay, so we need to write the Docker file and the Kubernetes manifest. Okay, so I will show you how to write. And we need to establish the secure connection between front end, backend, and DB. Okay, I will show you how to integrate the three tier application. Okay, so after that, we need to write the Azure pipelines. I will show you how to write the pipeline. So with this, you can able to learn a real time DevOps project for your portfolio. Okay. So before going to this one, let me introduce about myself. So I am Prasanna Kumar. I have overall 15 years of experience. Okay, I have worked on multiple DevOps roles. So currently I'm working on topmost MNC company. So I have working experience on multiple DevOps projects like banking, automobile, travel and transportation, medical care, and telecom domain, and big four companies. Okay, so I have multiple certification and AWS DevOps and Azure DevOps and AWS fundamentals and Azure fundamentals I have. Okay, so let's quickly start our live implementation. Architecture and tech stack walkthrough. Okay, so this is the architecture of this file. So let me see in the big photo. Yeah, here you can see multiple components. Okay, let me clearly explain. This is the Azure DevOps part, and this is the container registry part, and this is the RBAC pack, and this is the Azure Kubernetes part, and this is the static web app part, and this is the load balancer part, and this is the global user part. Okay, so let's quickly explain you each and every part. So Azure pipelines, this will help us to build your pipelines. Okay. So container registry, this will help to store your container images. Okay, your application images. Okay. So Azure Kubernetes services, this will help your application to serve from the Kubernetes services. Okay. In other words, so Azure Kubernetes services will host your application in container environment. Okay, so this is Nginx load balancer part. Okay, so this will help us to route your traffic to backend. Okay, backend Azure Kubernetes services. Okay, this is a static web app where you can able to host your front-end application to global users. Okay, so let me quickly explain each and every part. And also we have managed identity. Okay, so this will be helpful to pull your Docker image from Azure Container Registry to AKS cluster. Okay, so this is a role. We need to create a role assignment. Okay, which will have a image pull permissions. Okay, we need to create with the help of a Terraform code. Okay, let's start from each point, each perspective point. So when a user try to hit the application, he has a DNS name of a static web app. Okay, this is a dynamic URL. So this will be accessed by global users. So when he will try to open that portal, so when he see the, yeah, when he see the portal, so he will try to click this specific policies. He will like this, he like this policies, so he would like to purchase. So he fill the details like yeah, and then you need to fill the details. Yeah, save. Okay, so like this, the purchase, he will be purchase the all the policies whatever he need. Back to policies. So once you purchase, the details will be, let's see, once you purchase, so the details will route the traffic to backend public IP. So in the public IP, we have Nginx load balancer. It is a public IP. So it will be route your traffic to ingress pod. Okay. So where ingress pod will be routing traffic to backend path of slash API. Okay. So we have our slash API with integrated with backend services. Okay. So this is the backend services where this is a cluster IP. That means it will be accessible in cluster only. Okay. So we have a port 8080 so that the traffic will be routing to the pod. Okay. So in the pod we have a Spring Boot application. Okay. So this will be process your data and store the data to the MySQL DB. Okay. So that MySQL host details and user details and password that already I exposed with the help of a with the help of a secret that will be stored in AKS cluster only. Okay. So like this, your data will be stored in AKS. Okay. So once the data is stored, so now admin would like to check the details of policy details of customers. Okay, click here. 1, 2, 3. Yeah. So here you can he able to see the all the policy details. Okay, this is the customer details in email. So policy, this is the policy he purchased. This is the premium. So this is the time when he purchased. Okay. So this is the simple application where user can purchase the policies and admin can able to check the purchased policies. Okay. Yeah. This is the workflow of the whole application. Okay. So now see the how the from DevOps perspective you can see now. So here we have the Azure DevOps part. So we have a developer. So he will develop the front end application and back end application. Okay. So when the code is ready, he will push the changes to Azure repository. Okay. So we have Azure pipelines. So based upon configurations, the pipelines will be triggering, and we have pre-infra pipeline and infra pipeline and ingress pipeline and front-end pipeline and back-end pipeline and the cleanup pipeline. Okay. So first come to pre-infra pipeline. So pre-infra pipeline, so that will be creating Azure Container Registry and resource group. Okay. Only resource group and Azure Container Registry will be creating. Okay. So next come to infra pipeline. So this infra pipeline, so the resources like Azure Container Services and static web app, so and RBAC role. So these resources will be created with the help of an infra pipeline. Okay. So after that, Nginx load balancer, that means helm pipeline. Okay. So these help pipeline will help us to deploy the Nginx load balancer in AKS cluster. Okay. So that Nginx load balancer will generate a public IP. Okay. So this public IP will be helpful to route your traffic from front end to back end. Okay. So since this is a insecure IP address, we need to make it as a secure IP. Okay, that is the one-time activity. So I already configured. I have given the steps we need to perform in the AKS cluster. Okay, so I have given all the steps here. Yeah, I will show you in the upcoming slides. Whenever you are required, you can show you. Yeah. So that infra pipeline that Helm pipeline will be deploying Nginx load balancer. Okay. So now with this, all the components are deployed. So now come to front end pipeline. Okay, front end pipeline. So pipeline will be triggered when a change is detected in front end folder. Okay. So pipeline will build your application and publish this application as an image to Azure Container Registry. Okay. So that means so your application is packed as a image and stored in Azure Container Registry. Okay. This is the build part. Come to deploy part. So with the help of a deploy stage, so we have a Kubernetes manifest. So that will be deployed with the help of a kubectl commands. Okay, once the kubectl command deploying your Kubernetes manifest, so that will be deploying these all resources like backend 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 deployment and MySQL stateful set. Okay, and also this will deploy the ingress ingress controller. So once it is deployed, so after that we need to update the public IP in ingress so that it will know that the traffic will be routing to ingress. Okay, ingress port, then it will route to the backend. Okay, so I will show you clearly in the upcoming slide. Okay, so with this front end committed, same vice versa backend also. So front end will be deploying static web app. So backend will be pushing image to Azure Container Registry. Then it will be deploying in your AKS. Okay, a small correction. So front end is deploying. It will build and deploy in static web app, and the backend will be build your application push to Azure Container Registry. So with the help of a deploy stage, we will be deploying your Kubernetes manifest in AKS. Okay, so my ingress control will be deploying. So backend. Spring Boot will be deploying and the front and DB also deploying. Okay. So once the whole backend and front end pipeline is completed, so we have cleanup pipeline. So with the help of a cleanup pipeline, we can all delete all the resources in the specific resource group. Okay. So this is the whole architecture of this application. So now come to how the traffic will be routing. So we have users, he will try to access the policy. So when he try to book, when he try to purchase the policies, the traffic will be route to the backend path, backend the public IP. So we already configured in the environment API. Okay, so these will be route your traffic to Nginx load balancer. Okay, the Nginx load balancer, Nginx load balancer will route your traffic to ingress pod. Okay, so we have in the ingress pod, we have configured your backend service like a slash API. So when a front end is hitting the slash API, the traffic will be routing to backend services. So in the backend services, we have this port. This is Spring Boot port, Spring Boot application. So we have the cluster IP service. Okay. So this Spring Boot will be process your data and store your data to the corresponding MySQL DB. Okay. This is the flow. Okay. So when you try to update your image, so kubectl will update your latest image. So this AKS have a RBAC, that means have a separate role that will pull the image from ACR. Okay, we have managed identity. So that is we have already created a service principal and we established a service connection. The same it will acted as a managed identity. Okay. Yeah, this will be I already shown in the Terraform code. The upcoming slide you can able to know better understanding. So environmental setup, okay. So prerequisites. So we need to procure the Azure subscription and we need to create a Azure DevOps organization. Okay. So two, local tool setup. So we need to install all these tools. Okay. Node.js, Visual Studio Code, Git, Maven and Java 18. Okay. So three, Azure pipeline agent. Okay. So this optional one. If you would like to use your own one, also you can install VM and you need to set up. Okay. So four. So Azure Service Principal and Service Connection. Okay. So let's see project setup. Once the Azure DevOps organization is ready, you need to create a Azure repository. So after that, you need to create a front-end, backend, and IAC folder. So we need to follow the standard naming conversation, and we need to set up a Terraform backend setup. Okay. So these steps are already shown you in the last project. The same this project is same for all projects. Okay, you need to create a ADO, you need to create a project, you need to create a repository, you need to create a front end and back end and IAC folder. So this is the standard name we need to follow. Okay, yeah, let me show you that one. So you can see. So pipelines will be stored in Azure pipeline. So this is the backend code. Okay. So front end code in front end folder. So infrastructure as a code. So that code is in this specific folder. So this is the standard name we need to follow. Okay. If you have any images or any steps, you need to paste here. So this is the images. So related to this application, I have pasted directly here. Okay. You just ignore. So if you have any MySQL DB details, all the documents we can kept in the base folder. Okay. Yeah. So this is about environmental setup. Okay. Let's see. So how to create the front end and back end and how to deploy or how to develop your application. So front end, back end, and DB development. Okay. So once your repository is ready, you need to clone locally. Okay. So after that, you need to create a front end folder, and you need to pass this command so that basic React.js project directory will be creating. After that, you can make a changes according to your application. Okay. So after that, you need to create a backend development. So I have told you in the last projects how to create a Spring Boot application with the help of a Spring Boot initializer. Okay. Yeah. After that, once the backend code is development is completed, so you need to integrate your backend, front end, backend, and DB. Okay. So how the work will be happening in the locally. Okay. After that, you need to create a Docker file for your backend application. Okay. Since you have deployed your our backend application in AKS, so you need to write the Docker file and Kubernetes manifest for your AKS. Okay. So you need to write a two Kubernetes manifest for your application. This is the backend application. This one is for backend application. Another one is MySQL. Okay. So you need to write the two one, and another one is you need to write the ingress part. Okay. So this is the main file that will route your traffic from Nginx load balancer to your applications. Okay. Yeah, I will show you how to write. I will show you the code. Okay. Yeah, let's see. So starts with the front end application. Let's go to walk through our code. So once you pass that command, so this command will help. Yeah, nps create. Okay, you need to give the app name. So you can give any name. So better to give the front end name only. So this is the standard project structure. Okay. So package.json. Okay. This will contain all the dependent versions and components and the syntax scripts. Okay. This is the env file. So where your traffic will be routed from front end to back end with the help of the env file only. Okay. So in some projects they will hide this file, and so they will enable this through some environment variables. Okay. So here we have, right. So you can see this is the static web app. So they don't directly inject your backend path in the code itself. So simply they will create a environment path. So where they will be write this environment variable. Okay. So like this, the front end will be routing the traffic to backend. Okay. Yeah. Go to the code. Okay. Let's see the SRC code. Okay. So this is main dot Jax. This is a Vitara project. Okay, that means so in React.js there are multiple flavors is there. So one of them is VT flavor. Okay, so this is the code related to front end, and I have already written some code, so that is having in separate folder. Okay, so you can see, so all is imported here. So all code is importing here. This is the policy listing code UI. Okay. So this is the purchase uh, JS file. This is the policy details. Okay. So this is the DB. So DB login and DB dashboard. Okay. So this is the API. So how to route the traffic from env to front end. So this will tell you. Okay. Yeah, okay, this is all about front end code. So this front end code doesn't have a business logic. This is just a front end UI only. So with the help of env and API, here we have API, right? So this one. So the traffic will be routed to the backend. So backend Spring Boot application will be process your data. Okay. So all the policies details also will come from backend only. Okay. So nothing will be stored in front end. It is just a UI only. Okay. Yeah, let's go to backend. Yeah, backend. So I already in the last project I told you how to create a Spring Boot application, how to create with the help of a Spring Boot initializer. Okay, the same process you can follow. Okay, once you downloaded the zip file, so you can unzip the folder in backend folder. Okay, so that will create SRC and form.xml. Under that we have Maven, Java, Insure portal like this. Okay, let's see the code. So this is the form.xml. So where it will containing the group ID, artifact ID, and properties and the dependencies and some Spring Boot related dependencies and the database integrations after some plugins. Yeah, these all details will be present in founded.xml. Okay, next to go to, yeah, this is the entry point for your application. This is the just entry point for your application. Yeah. So after that we have models, we have repositories, and we have web. Okay. So this is related to controller. So controller is main part. This will handle your each and every API. Okay. So policy controller. Okay. This is related to policy controller. So your data will be come from here. Okay. So purchase controller. So when a purchase is happening, so that details will be passed by this controller. Okay. So this will integrated with backend and will be stored in DB. Okay. Yeah. Purchase. This is the models and these are the repositories. So this will be helpful to process your data to DB. Okay. So whether you need to write the data to DB or whether you need to fetch the data from DB. So you should require these two: policy.java, purchase.java, policy repository, and purchase repository. And there is a DTO is there, purchase request, where so this will helpful to enter the details in DB. Okay. Yeah. This is all about your code of backend. Okay. So now, so front end is completed and backend is completed. So how front end and backend will be integrating? Okay, and the DB is integrating. Okay, let's see. Yeah. So with the help of a front end, so we have env file. So we have the API. So from front end to backend will be route the traffic with the help of this one. Okay, this API. Okay. Yeah, like this, front end and back end integration is completed. From back end to DB. Okay, let's see. So there are multiple options is there how to route the traffic from back end to DB. Okay. So now I followed the standard process. So here we have application dot properties. Okay, this is the main file. It will fetch. It will route the traffic from backend to DB. Okay, with the help of this key value. So these key values will be fetched from deployment. Okay, so in the code nothing will be saving. Okay, in the Kubernetes manifest only all the details will be saving. Okay, in other words, so to route the traffic from backend to DB, so we should require we should store the details in separate environment. So we have created that environment. So whenever it required, when the pass is there, when the backend Spring Boot application is process the data, so it will fetch the details and update the details in the Spring Boot and it will pass the data to DB. Okay. So these details will be coming from Kubernetes deployment. Okay. Yeah. This is how front-end and back-end and DB's integration is happening. So let's go to Kubernetes manifest. This is the Kubernetes manifest. Yeah, here you can able to see. So this is the environment. Get database URL. This is the database user. This is the database password. So I have stored the username and password in secrets. Okay. So this is the MySQL. Yeah, this will store my secrets. Okay, MySQL username and password. This is a encoded one only. Okay, encrypted one. Yeah. So we have updated with the help of these secrets, and it will be passing here. Okay, this MySQL will be utilizing that username and password, and it will be creating. Okay. Yeah. Now come to deployment. Yeah. Come here. So we have created a MySQL secret type. That secret will be utilizing here, and it will be referring username, and it will be fetching the username, and so when it will write the traffic, so it will take the username, passwords, and database URL, and the data will be processing. from backend to MySQL. Okay, this is the workflow. Hope you can understand. So after that, come to Docker file development. Okay. So since this application will be backend application will be deployed in AKS, so we need to build the application and deploy in AKS. So for building your application, you require a Docker file. So let's see the Docker file. So this is a multi-stage Docker file. Okay. So where this will pack your application and so this will build your application. Okay. So this will be run your application as a runtime. Okay. So we are using a Maven 3 version and we are copying all form.xml and certify. Okay. After that we are packing with the help of a mbn command. Okay. So this will generate that targets slash jar files. Okay. So that is the this will build your application, and after that this will run when a application is deployed. Okay. Okay, you can see. So this is the we are using this image and working directory. So we are copying your generated jar file and uh, stored in this inbuilt multi-stage layer. That means it is copying the specific jar file from this build image to runtime stage. Okay, the name we are renaming as a app.jar. Okay, after that exposing the port. So when this image is deployed, so it will start at the command with java fnjar and app.app/app.jar. Okay, so like this, so application will be building and deploying in the AKS, and once it is deployed, this application will be up and running with the help of this command. Okay, yeah, this is all about Docker file. Moving forward, we have Kubernetes manifest. Okay. So, so now we have ready our image. That image will be shipping to Azure Container Registry. So, okay, that will be handled by the front end. That will be handled by the backend build pipeline. Okay. Now come to backend deploy pipeline. Okay. Deploy pipeline is nothing but deploy stage. Okay. With the help of a deploy stage, your image will be deployed in the Kubernetes services, Azure Kubernetes services. Further, to deploy your image in the Kubernetes services, we should require a Kubernetes manifest. Okay, so manifest will require. So that we need to create the Kubernetes manifest. Let's see the Kubernetes manifest. Go to the code. So in the backend only we have stored. So whatever the related to this application like Docker file or Kubernetes manifesto, you should store in the corresponding directory only. Okay. If you have any containers or Kubernetes or any related stuff, that will be stored in the corresponding application. Okay. So my corresponding application is backend. So I'm storing here only back Docker file and Kubernetes manifest. Okay. Yeah, let's see. So this is the deployment. We have two replicas and we have a template. Under template we have image name. So this is the Azure Container Registry name. This is the image name. Okay. So after that I'm given the container code, and after that I'm giving some environment variables that we utilize to communicate with the backend. Sorry, not backend, DB. Okay. So after that, I am setting some readiness and liveliness props. So these help us to check the health of your application. Okay. So we have a HTTP path. So that is activator/health. So it will be going to check the health with the port of 8083. Okay. So readiness prop and liveliness prop is both will be checking the status of that one. Okay. So this is resources quota. That means so we are allocating specific amount of a CPUs and memory. So it will be using within the limit of that resources. Okay. So we are requested for 250 ml. So the limitation should be 500. That means we have a availability of 500 ml. So we can use at least 250 and above also you can use. Okay. So that is about deployment. Now come to service. So let's see. So this is the deployment. Once this is deployed, once the parts are deployed, So now we need to access this port to external world. So for that purpose, we need to deploy the service. Okay. So we are using the service. So we are using a cluster IP service type, and our port is 8080. Okay. So that means your port will be open for 8080 from service. So from service port to will go to backend port. Okay. Backend port is 8080. You already configured. Okay, this is about to deploy that YML. So now come to MySQL. So till now we have deployed this front end, so this backend. So now we need to deploy the MySQL. So to process the data, we should require a one MySQL only. It is fine. So in real time world, so they will use real Azure MySQL. Okay. So that will be I already explained you in the previous project. So in our project, see, so we have multiple projects, right? This is the insurance aggregator. In our previous project, so we have used AKS ACR and original MySQL DB. Okay. So the traffic will be routed from front end to back end to original MySQL. Okay. So in this project, the traffic will be come from static web app, then AKS and uh, MySQL. Okay. So you can create your own project also. So you can kept a static web app. So after that you can kept a AKS backend application, and you can kept a original MySQL DB. You can try that process also. Yeah, that is what my suggestion. Yeah. So move forward. So where we are? Yeah, the Terraform Kubernetes code. Okay, MySQL. So we are creating a MySQL secrets. So this will help us to store username and password. Okay. So when backend is try to hit MySQL, so this will use and this will communicate the MySQL, the DB. Okay. So after that, we are creating a persistent value client. So this will save your data in persistent value client. That means if the MySQL is destroyed, MySQL part is destroyed, so the data will be stored as a persistent value. Okay. This will be saving. Okay. Till the cluster is available, it will be saving. Okay. Yeah. So now we are creating a actual MySQL deployment. So we are using a one replica, one that means one pod. We are using a container images MySQL and port is 3300, and after that we are using this one. Okay. So we are using environment variables. So MySQL row password and MySQL database. These all things it will be fetching. Okay. This is secret referring. Okay. We have created secreted. Here it is referring. Okay. This is the where you will mount your value. Okay. So this is how our persistent volume claim is. So attaching to this pod. Okay. Yeah. So after that we are creating a service. This is a cluster IP. That means it will be accessible internally only. Okay. This is about Kubernetes service. So we need to create a one backend deployment, one DB deployment. So here we have one replica. Here we have two replicas. Backend deployments will be communicate to cluster IP service. From it will go to pod. Okay. So where we have a persistent value client, so that will be store all your data. So if the pod is deleted also, that will be saving in your cluster. Okay. If the cluster is destroyed, we can't do anything. So to overcome this issue, we already created a one more project, that is a hospital consultancy project. So where original data will be stored in original MySQL. Okay. This is the process of front end to back end to DB. Okay. So let's see the infra code next. 4. Infrastructure as a code, Terraform. So first of all, we need to write the Terraform code that will provision your Azure Infra resources. Okay. So after that, we need to follow the project structure directory. Okay. So after that, you need to configure the Terraform backend for your infra resources. Okay. 4. You need to get the Azure service principal, and you need to establish a service connection, and you need to utilize in the pipeline. Okay. This step I already explained from project fund also. Okay. After that, you need to deploy using Azure pipelines. You have pre-infra pipeline and infra pipeline, and also cleanup pipeline, where all resources will be deleting with the help of a cleanup pipeline. Okay. So after that, you need to verify the all the deployed resource services. Okay, let's go to the code and review this one. Yeah. So go to here. This is the AC folder. Okay, this is the pre-request. So let's see. So with the help of a pre-request, so we need to create. So I already told you. So we have split this into multiple parts. This is the pre-infra and this is the infra. Okay, and we have nginx pipeline that will provision this part. Okay, so for now, so we need to create a Terraform code for this all resources. Okay, let's see. So pre-infra, so this will create Azure resource group. Okay, and also it will create Azure container registry. Okay, yeah. So backend that variable where your backend data will be stored here. Okay, so after that, so terraform.tfs where you can able to save all our key variables. Okay, related to the variables. Okay, key value should be stored here and variable should be stored here. Okay, that will be injected in the front end in the main.tf. Okay, to standardize your resources names, we are following this one. Okay, so name conversation will be starts with project name, application name, and environment and location short name. Okay, so the same thing you are given in terraform.tf. Okay, yeah. So let's go to next. So with this you have completed creating of resource group on Azure container registry. Okay. Yeah. So after that, we need to create the rest of the part like Azure Kubernetes services and static web app and RBAC role. Okay, let's see. Now go to the code. Yeah, this is common for all application. I don't need to explain again. So to make a customized names, you can do like this: rg name local dot name prefix slash rg. That means so name prefix will be adding, and at the end you can adding slash rg. Okay. So the same thing you can refer in the yeah you can refer in your names. Okay, like this your resource names. Okay. So I no need to explain each and every time this one. So this is a common for all Terraform code. Okay. So this will fetch the existing data of your resources and container registry. Okay. Yeah. So this will create the static web app. Okay. Yeah. With this, it will be creating a default Kubernetes cluster. Okay. So where it will having a node pool details like node pools you require one and virtual machine is one and identity is a system identity. Okay, system assigned identity. Okay, so we are creating a Azure Kubernetes cluster with the minimal changes. That means we need to give the name, location, and resource group and the DNS name of that Kubernetes cluster and node pools. How many nodes you need to require? I require one node with VM size. Okay, yeah. So identity. Finally, what is the identity you are giving? So this is system assigned unit identity. Okay. So after that, you need to create a role. Okay, this is a role assignment. So this AKS having the capability to pull the ACR image. Okay, that is the scope I am creating here. So I am creating a RBAC role. So that will have a capability to pull the image from ACR to AKS. Okay, so that is the so these are resources we need to create. So we have created static web app, we have created AKS, and we have created a RBAC role. Okay. Yeah, with this you have completed Terraform code. So go to dev. So where you need to mention all the details. Okay, existing ACR name and the ACR resource group. So why? Because so this is created main.tfl will be creating once the pre-infra is completed. Okay. Now we need to make a reference. Okay. So here you need to give the reference. So for this purpose, so you need to pass the details like yeah. Here I will show you. So name need to come from there. So the name is same for pre-infra and infra. So that I'm just directly importing here local.rg. That means this rg name will be getting. So in the backend also you can see infra also. So same name we are creating. Yeah, the same name we are following. So so the same name will be it will be taken. Okay. Yeah. So you can also instead of like this you can give var dot rg. Okay, whatever you are referring you can give that one. So var dot you can give that name also fine. Okay, or else you can take from here local also. That is fine. Okay. Yeah, with this we have created Azure Kubernetes services and static web app and RBAC role. Okay. So now we need to install the Helm. Yeah, let's see go backend also. Here it will store the backend details. So TF state file will be storing all the resources related information. Okay. So dev.tf parts. So where key values will be storing here. Okay. Yeah. Let's move to pipelines. How to implement. So once the code is ready, so we need to create a pipelines. We have pre-infra pipeline. We have infra pipeline. Okay. Let's see how to create. 5. CI/CD pipeline with Azure DevOps. Okay. So we will write our code with the help of a YAML based only. These are YAML based pipelines only. Okay. We are not creating manually. This is a automated way only. So we have pre-infra pipeline, we have infra pipeline, we have ingress pipeline, we have front-end pipeline, we have back-end pipeline, we have cleanup pipeline. Okay. So I'm telling from starting of this wire. So pre-infra will be create your pre resources. Infra will create the main resources. Ingress pipeline will create your Nginx load balancer. So front-end pipeline will build and publish Docker image to not AKS. Static web app. Static web app. Okay. And the backend. So this will build and publish your Docker image to ACR. Then it will deploy your Kubernetes manifest with AKS. Okay. So after that, clean up pipeline. This will delete all the resources. Okay. Let's quickly start one by one. So pre-infra pipeline. So go to here. So here you can see. So infra pipeline. So ingress, infra pipeline, front end, cleanup, backend pipeline. Okay, let's see the pre-infra pipeline. So we added a trigger. So that means this pipeline will be triggering manually, and we have added the VM. Okay, this is a Microsoft agent. So we are adding the Terraform working directory. This is the working directory. So after that, I have added the tasks. So these tasks will execute. It will install the Terraform if it is not available. If it is available, it will throw the Terraform version. Okay. So after that, so this will initialize your Terraform code. Okay, with the help of a Azure subscription ADV. This is the service connection. Okay. So you already create a service principal. So that will be attached to the service connection, and that will be utilized in pipelines. I already explained you from part 1 onwards. So you can cross verify. So go to static sorry project directory and service principal. So you can this is the ADO, this is the service principal, service connection. So go to service connection. This is the ADO. Okay. Usage. So this is the usage. How many times it is used. Okay. I will tell you how to create the service principal. So with the help of a script. So I have given in that first project. The script is given in that first project. So once you execute it, so we'll get the backend. You can get that backend all details. So that will be saved in your service connection while creating, like a secrets, client ID, uh, password like this. You need to save. Okay. So this will be inside your Terraform code. So this will validate your Terraform code. Okay. So this will plan your Terraform code, and this will deploy your actual Terraform code. Okay, apply. This is the standard process. Terraform initialize, Terraform validate, Terraform plan, Terraform apply. Okay. So once you have created the pipeline, go to pipeline. You need to create. I already told you how to create the pipeline. So once you created, so this will deploy your resources. Okay. Yeah. Go here. This will follow the steps. Apply, you can check here. Yeah, so Azure resource group is created and container registry is created. Okay. So now with this you have completed the pre-infra pipeline that will creating the container registry and resource group. Okay. So moving forward. So now infra pipeline. So this will provision all your rest of the resources like Kubernetes services, RBAC role, and the static web app. Okay, let's go. So we need to the code is same for that one also, infra pipeline also. So but here we need to change the working Terraform working directory. So our main file will be stored in IAC folder. So where you need to give the details. Okay. So for pre-request we have given this working directory / pre-request. You can see pre-request. Okay. This is this IAC folder only. Okay. So once it is created, go on infra. So this code is crossed multiple times and validated. Okay. So this will deleting the Kubernetes, this will creating the static web app and Kubernetes cluster and RBAC role. Yeah, role assignment. Okay. So three resources will be provisioned. Okay. Here it is. Azure Kubernetes services, static web app and RBAC role it will be creating. Okay. Once it is completed, let's move to cross check. You need to cross check all the things. Okay. Here you can see this is my resource. This is the standard name I have followed. Okay. Here you can see Kubernetes services. Okay, this is the static web app. This is the container registry. So you can observe the name. So you need to follow the naming conversation of each resources. Okay. So this name is accepted by the Kubernetes services, but that name is not accepted by container registry. So that I have given a different format. Okay. The format we need to follow from Azure naming conversation. You can search in the Google naming conversation for Azure container registry. Okay. Yeah. Under that you can able to see all the details like so repositories. So I already created repository. I mean I have already done a CI/CD pipeline so that you can able to see the repository and this is the image tags. Okay. Yeah. Like this you can cross check each and everything. So this is the AKS. So I already told you how to interact this AKS with the help of a kubectl. Okay. kubectl. So you can see all the Kubernetes resources. Why? Because this AKS is very slow in GUI. Okay. But workloads. You can check the workload. Yeah. It will take some time to load. So, so I made a CLI. So, so since long time it is like that only. You can see the workloads. So you can see this is the backend application. So this is the ingress load balancer. Okay, Nginx ingress load balancer. So where this will be route your traffic to corresponding backend. Okay, yeah. So here you have right from public API to will route your traffic to ingress part. That means ingress load balancer. From here it will be based upon part. It will route traffic to backend. Okay. So here you can see parts. So all things. So it is very difficult to see all the things. Okay, this is the MySQL one. Where is the backend? This is the backend. Two backends, one front end. Okay, I already deployed so that you can able to see like this. So best way to use Kubernetes kubectl. Okay, just refresh this page. Restart. So now ingress pipeline is infra pipeline is completed. So this will create Azure Kubernetes services, static web app and our backdoor. So now we need to create a Nginx load balancer. You need to install the Nginx load balancer. So once it is installed, it will generate the public IP. So that public IP will be added to static web app and ingress part of a AKS. Okay, so that it will be route the traffic to corresponding backend services. Okay, like this integration will be happening from front end to backend. Okay, then to MySQL. Okay, let's go. Let's go to ingress pipeline. Ingress pipeline. Okay, this is the ingress pipeline. So this command will help to log into that AKS cluster. Okay. So with the help of this command, so we are installing the Nginx load balancer. Okay. So this is with the help of help commands only. So this will be adding the your repository. So this will be updating your repository. So this command will be deploying actual deployment of the Nginx load balancer. Okay. So it is creating a new namespace, and this is the package name. This is the package name. The Kubernetes AKS. This is the replica count. This is the node selector. You require a Linux. This is the ports it will be opening 480 and 443. This is the 443. Okay. So with this ingress will be installing. Okay. Nginx load balance will be installing. Okay. Let's see ingress. Yeah. Here you can see. So installation is completed. Okay. After that, this suggesting was sometimes I have followed the same one. These suggestions you need to follow. So you need to create a secret so that will secure your Nginx public IP. Okay. So once you install the Nginx load balancer, so this will generate a public IP, that is a insecure public IP. Okay. So to interact this public IP with the front end, we need to make this as a secure IP. Okay. To make it as a secure IP, you need to create a secrets. Okay. You need to create a certificates and you need to make it as a secret. Okay. That is the one-time setup I already done. So that should be done from your local CI only. I will let me where is that? Let me show you that one. Yeah. So that will be done in AKS. Okay. So you need to pass you need to create this namespace. After that you need to give this one. You need to install certificates. So you need to get the pods. Okay. So like this certificate manager will be installing. Okay. After that you need to create a file and you need to update these things. Okay. And you need to deploy. Okay. Like this. Once you have done that one, so now your public IP is a secure IP. Okay. So not fully secure, at least 90% approved. Okay. Okay. This is once you need to update your code in here like this. This will I will explain you. Yeah. This is the one-time setup. So in the AKS you need to follow this. This is a 2-3 task only, 2-3 minutes work only. Yeah. So with this, so you have completed all the setup. So installation of a Nginx load balancer, static web app, and creation of a AKS and RBAC and ACR and resource group. All the content is ready. So now only application deployment is pending. Okay, let's see. So we have front-end pipeline, we have back-end pipelines, and cleanup pipeline. This will delete all your resources. I will explain you at the end of this session. So front-end pipeline and back-end pipeline. Okay. So front-end. So these will build your application. So these will build your application and publish to the static web app. Okay. So back-end pipeline. So these will build and publish the publish this as a Docker image to Azure container registry and deploy with the help of a Kubernetes manifest in AKS. Okay. Let's see. Yeah. So now the all the infra resources are ready. Okay. So static web app for front end and AKS for backend and DB. Okay. So with the help of a front end pipeline, so we will build our application and so publish as a artifact in static web app. Okay. So now come to backend application. Okay. So we need to build your application and pack. We need to build the application and we need to make it as an image with the help of a Docker command. So it will be create the Docker image that will be pushing the image to Azure Container Registry. Okay. So with the help of now come to deployment plan. With the help of a kubectl, so we are deploying our Kubernetes manifest in the AKS cluster. Okay, like this application is deployed. So now we need to update with the latest image. Okay, with the help of a kubectl, so we are pulling the latest image, this ACR latest image, and it will be updating your image in the AKS cluster. Okay, this is the workflow. Okay, let's see the code. So go to here. So you have front-end pipelines. Okay. This is the build part and this is the deploy part. Okay. So let's see the build part. Okay. So this will help us to trigger this pipeline will be triggered when a change is detected in front end. Okay. So this is the secrets where front end web token will be stored. Okay. So I told you many times where to stay. Okay. This is the Azure image. Okay. So now see the build steps. This you are setting the nginx no node version. Okay. So this will build your application. Okay. So working directory is this one. So this will install required packages and this will build your application. Okay. So after this will publish your image as a publish your application as a artifact. Okay. Yeah. So now come to deployment part. So once the build is successful, the deploy stage will be starting. Okay. So this part will download your artifact and this part will deploy your application to the static web app. Okay. So for this purpose, you require a web token that we need to collect from your static web app. Okay. So once you are trigger the pipeline, your application will be up and running. You can see, yeah, front end. So we have two stages. Stage 1. Yeah. So this will build your application. Okay. So this will publishing your application as a artifact. Okay. Not deployment pair down. So this will download your pipeline artifact. Okay. So this will upload your application as a artifact in static web app. Okay. So after that, the application will be accessing here. Okay. Click that one. Yeah. Yeah. This is the application. So this will be loading from backend. Okay. Sometimes it will some lag is there. Okay. So admin. This is the admin section. This is the you can pass the details also. Admin 1 2 3. Yeah. Now you can see. So data is loading from backend. Okay. These are both. I'm closing one window. Yeah. So like this, you need to create the front end application. Okay. So now come to backend application. So this also you need to split into two. So one is build and publishing image to Asia. Another one is deploying your Kubernetes manifest to AKS and updating your image. Okay. So let's see. Let's go to backend. So these are key variables. It will be utilized for deploying your Kubernetes manifest. Okay. So let's go to build part. So build and push Docker image. Okay. So first we need to build. Okay. So this part will build your application. Okay. And pushes the image to corresponding container registry. Okay. So you need to change directory Docker build dot. That means the current directory, whatever the Docker file is there. So it will taking and it will be building. Okay. So go to backend. So we have Dockerify. Yeah, this is the Dockerify. So this will building. It will generating one image. Okay. So that will be tagging with this one, ACR login server, image name and image tag. So where did this will be coming from? ACR login server and image name, image tag. So ACR server, ACR login server, this is the server, okay? This is the ACR details, okay? You need to update there with this image name, slash image, this is the image, okay? Slash and image tag, this is the image tag. Build ID as a image tag, okay? So this will be tagging and it will be building and the same image is pushing to your container registry. Okay. So in the previous script, this step will be made a authentication. That means you are logged into the ACR. Okay. So we already established the service connection. Okay. So we have saved all the details like username and password. Okay. Go here. So this is the container registry. So here you can able to see access keys. Okay. So you have a login server name and username and password. So these details will be saved in pipeline. That means in the variable section you need to save. Okay. So with the help of a yeah. So with the help of a ACR credentials, it will be importing and that will be utilizing for ACR login. Okay. So once it's logging, you need to build and push to the container registry. Okay. Once the build step is completed, automatically that will be log outing. Okay, the task is completing. So now we need to deploy to AKS. Okay, yeah. So with the help of a G script, so we are logging to AKS cluster. Okay, so AZ AKS get credentials. So we have resource group name. So we have cluster name. Okay. So with this, it will log into AKS cluster. Okay. So we have established a service connection. You can see this one. Yeah. Azure subscription. Okay. ADO we have given. That is the service connection. Okay. So once you are logging, so now it's time to deploy your Kubernetes manifest. Okay. So now see, this is the script to deploy your AKS Kubernetes manifest in AKS. Okay. So we need to give the manifest path. So kubectl apply -f manifest path. So go to manifest path. So backend slash Kubernetes. Here where all the Kubernetes scripts is manifest is saving. Okay. So it will be taking that one and deploying. Okay. So once the deployment is completed, so now we need to set the latest image. Okay. So this command help us to update your latest image. Okay. So gives it real image deployment backend equal to server image name and image tag. That means same build ID is treated as a image tag. Okay. So the same image is pushing and same image is updating. Okay. So once it is deployed, so we'll get this one. See, build and pushing the Docker image. So deploying Spring Boot application to AKS. Let's see. Yeah. So this command will help us to log into the ACR cluster, ACR container registry. Okay. So this step will help us to build your Docker image and push to the container registry. Okay. See that these are the build steps. So we have a Maven task that will pack your jar files, right? So for this purpose, it will take a long time. Okay. Yeah, I'm straightforward and going the last. Yeah. So these are steps. Okay. So this is the image. This is the content register image, and this is the tag 684. Okay. This is the task. Okay. So after that, come to deployment. Yeah. Here you can see. So this indicates that you are able to log into the AKS cluster. Okay, merging AKS as a current context in current directory. That means in your current CLI. So we are setting that one. Okay, we are working with the AKS. Okay, this indicates you are working with this one. Okay, next, moving forward, we need to deploy. So we have given the commands right, kubectl apply manifest path. Okay, so with this, sorry, with this, all the Kubernetes machines is deploying. See here. So backend we are using this path, and deployment, this is the service, this is the ingress, this is the secret, this is the PVC, this is the stateful set, this is the service, this is the yeah, this is the latest image. Okay, so this will be deploying your Kubernetes manifest. So last step will updating your image. Okay, so like this your application will be updating. Okay, now I will tell you ingress.yml. Now you deployed our application, right? How the traffic is going? So static web app, we have public API, we are given in the env file. So that will be routing the traffic to ingress part. So when a ingress is deployed, so ingress part will be detecting and route the traffic to corresponding API, backend API. So we have backend service. Okay, so it will route the traffic to backend service to backend pod. Okay, so this is the Spring Boot application. So we are exposing MySQL hostname and username password. So it will be taking and so it will fetch the data or write the data. So that will pass the data to MySQL. Okay, like this workflow will be happening. Okay, yeah, this is how the CI/CD pipeline will be happening. Okay, so with this front end and back end pipelines are completed. Application deployment and integration. Okay, so till now we have completed all this process. Okay, let's go to integration of front end, back end, and DB, and after that we will do the end-to-end testing. Okay, let's go to front end. Okay, so now we all deployed all the things. Yeah, we deployed all the resources. You have made a CI/CD pipelines that will deploy your front end application and back end application. Okay, now cross-check how the integration is happening. So we have front end. So, okay, so customer you can able to access this front end. So how the traffic will go to static web app to public IP. Okay, let's go to front end. So we have env file. So where you need to update your public IP. Okay, okay, let's see. This is the public IP address. So but we need to configure like this one. Why? Because we are not making any specific DNS. Okay, so to route this traffic internally, so I'm making as a NIP. You can go and search what is about NIP. Okay, yeah, so let me log in here. So kubectl get that. Yeah, okay, let me log into here. So I have given the commands from here only. So where this is the file. So go here. So this command will help us to log into CL line. Okay, to AKS test. Yeah, yeah. So CTL get all. Yeah, here you can see. So backend MySQL is running. Okay, services kubectl Kubernetes, and this is default one. So remove that one. So this MySQL. Okay, let's see all components from kubectl. Yeah, so certificate manager we install ingress nginx load balancer. Okay, this install. Okay, with the help of a help pipeline, so our nginx load balance will be installing and it will generate a dynamic IP. Okay, let's see. This is the part. So I already told you, right? This will create a ingress part, okay, and this will generate a dynamic public IP, okay. Yeah, let's verify that one. Yeah, this is the part of ingress, nginx ingress, okay. So this will be routing your traffic to nginx, okay, ingress. Yeah. So wait. So after installation of nginx, so this will create a your nginx part, okay. So what this is duty is to identify the ingress and route the traffic to the corresponding ingress, okay. So we have the code, the backend code. We have a Kubernetes manifest. We have ingress, right? So this is the ingress. Okay. We have a nginx. So we have a nginx ingress. Okay. So that what it will do is it will route your traffic to this ingress part. Okay. So we have public IP. So this will generate the public IP. So that will be utilizing for static web app. Okay. So from static web app, it will route the traffic to public IP from here. So we have a nginx ingress load balancer pod. Okay. So this duty is to route your traffic to corresponding ingress. Okay. This is my ingress where we are having all the details like this. Okay. So we have path API come to we have services slash API and we have services, we have backend API. Okay, like this traffic will be flow from to here. Okay, so this path is nothing but this is a public IP. Okay, so actually this is a public IP. So but so we don't have DNS, right? For we have made a configuration to use this temporary DNS name. Okay, so yeah, let's see. Yeah, you can see this one. So ingress nginx. Okay, this is the load balancer, nginx load balancer. So this will generate a public IP. 4.2, this is the public IP. So this is insecure public IP. Okay, I'm taking this one and I updated my ingress. Okay, the same IP is we are using for front end also. But so this is a since this is a insecure IP. So and also you don't have some specific DNS for this IP. So I made it as a like this. Okay. So, so even though traffic will be routed from front end to this one only, okay. So from here it will go to ingress part. From here, this will be treated as a this IP insurance dot port dot like this, okay. Front end to this host, from here to ingress part, from here to corresponding backend, okay. This is the how route is happening. So in order to access traffic from static web app to ingress. So it is since it is insecure one, static web app won't accept the insecure IPs, insecure host IPs. Okay. So I have made it as a secure IP with the following steps. So these following steps you need to follow. So simple steps only. Only two steps you need to create. You need to create a cluster issuer and you need to create a certificate manager. So you need to follow the two steps in AKS. So once you have completed, so this load balancer host name is acted as a secure IP. Okay, that will be utilized in static web app. Okay, the same you can use in backend ingress. Okay, ingress, your ingress part will be identify that ingress and route the traffic to the ingress and then it to backend service. Okay, this is the workflow. Yeah, wait. So let's see. This is the public IP. Okay, so I already now we need to verify ingress. kubectl get ingress. See, this is the this is the address, right? Okay, so backend ingress host. So this is the address. Okay, this is the port. Okay, that means traffic will be come from public. So then to this host. So this host is having the same IP address. So then it will be routing traffic to ingress your corresponding ingress backend port. Then to it will go to your service backend service. This is the workflow. Okay. I think hope you have understand all the things. With this, you have completed all the things. So now let's do end-to-end verification. So we made all the changes. We need to do verification. So let's create a data entry. So I need a health insurance. Someone need a health insurance. So they need to click this one. Yeah, you need to give some dummy name you can give. Okay. So he enter the details. He pay and purchase. Okay. Yeah. Your policy has been recorded. Purchase successfully. Okay. Back to policies. You have all these policies. So now cross check with the admin whether his record is saved or not. Admin, admin, 1, 2, 3. Okay. Enter. Yeah. So Frank. So his details is he purchased the all the things. So customer name, email, policy details, so premium and purchase at date. Okay. So like this, the workflow will be happening. So with this, you have confirmed that. Sorry. Yeah, what is this? So with this, you have confirmed that. So static data will be passing to backend. So backend public IP, it will route the traffic to backend. So for backend service, it will be passing data and stored in the MySQL. So this is confirmed. So how to confirm whether the data is saved in MySQL or not? Okay, let me show that one also. So let me log into MySQL. Yeah. So kubectl get the yeah. This is the kubectl ingress. This is the backend port. This is the MySQL port. This is the services, backend services. This is the MySQL. This is the deployment. These are replica sets. Okay. This is the MySQL. This is the stateful set. Okay. Do you know stateful set, right? Stateful set, right? Okay. Yeah. Now what we need to test whether the data is stored in MySQL or not. Okay. So for that purpose, I have given a command to log into MySQL. Okay. So instead of using the same one, so you can use this command. So MySQL data verification. So you can take this command. So this command will help us to interact with your MySQL pod. Okay. Yeah. Here we go. Yeah. So sorry. Go here. So after that, you need to log in with MySQL. Yeah. So now we have entered. Double time we are entering. Go to here. So we already log in. Show database. Show sorry spelling mistake. Yeah, here we go. So we have this many databases. My database is to the insurance. Okay. So I will let me use that one. Yeah. So you have set that corresponding insurance DB only. Now paste. Okay, we have two tables, policy and purchase. So let's open the tables. You need to select the corresponding table only. COLICY. Sorry, need to give the correct. Yeah. So you can see these are the policies updated in DB. That means your backend team will be updated in the DB. Okay, with these policies. Okay. Now change the policies to purchases. You are just yeah. So here you can see. So all the customer details which whoever they have purchased. Okay, they have created an email, full name, nominee, policy ID, health policy they purchased, the premium they have. Okay, this is confirmed that so front end data is saved in the backend. Okay, so with this you have completed this end-to-end implementation. So cleanup. So we have created these all resources. Now it's time to delete all the resources. Okay, we have created a cleanup pipeline. So that will delete all your resources. Okay, go and yeah, yeah. Sometimes it will be low cleanup. Continue. This will delete all your resources. Yeah, two tasks we have: Terraform installation and yeah, Terraform destroy. Okay, let's see. You can observe the all the details. So now the all the resources are deleting. You can observe here. Okay. So the, like this, all resources will be deleting. Okay. Moving forward, let's wrap up and what's next. Okay. We all learned how to create front-end application and back-end application. We all learned how to write the Terraform script. We all learned how to write the Azure pipeline. We all learned all the services about AKS and ACR and static web app. We all learned how to write the Docker file, Kubernetes manifest, and Helm commands, and also Azure commands. So, and also you will learn kubectl commands also. Okay. Yeah, this is all about this project. So, let's see you next project. Yeah, thank you. It's your Prasanna Kumar.